In this 30th video in my Color and Light series, I'm going to describe inclined planes, and it's all in my book, Ellen's Guide to Drawing Shapes, on Amazon. An inclined plane makes an angle with the ground, so it converges toward a vanishing point above eye level. Its shadow, or if this were a wedge, the base of the wedge, converges toward a vanishing point on eye level. Since the inclined plane and the shadow are connected, their vanishing points lie on the same vertical line, which I call the vertical vanishing line. This inclined plane is in one-point perspective since it recedes in only one direction and has true horizontal and vertical lines. The problem is that this near side is shorter than the far side, and that goes against depth cues, where things close to us should be longer and bigger than things in the distance. We can rectify that by turning it into a two-point perspective, where the top and the bottom recede toward a vanishing point over here. As a result, side A is now longer than side B, so that's good. The three-point perspective, however, doesn't work in this case. The vertical vanishing point needs to be between the two other vanishing points, but there are only two lines that are vertical, or supposed to be vertical, and in this image they look like rickety legs. If you want to draw something on the incline, like this green box, then you can call this vanishing point 1 and this one vanishing point 2 and have a new eye level. And you can see that the box converges toward these two vanishing points. If you want to add a third vanishing point, it should be vertically below the box to agree with gravity, even though this line is not perpendicular to the eye level that we're using. I think this three-point perspective looks better than the last one where I showed you the two rickety legs, because now we have three sides that are affected. If a road curves up or down, each segment converges toward a vanishing point above or below eye level. And since they're connected, these vanishing points lie on the same vertical line. You can use this approach to draw a simple spiral staircase and start here with one-point perspective, and then all the other boxes are in two-point perspective. And all the vanishing points are on eye level because the stairs are parallel to the ground. Similarly, when a road curves, each house converges toward a vanishing point on eye level, since all the houses are on the same level ground as the viewer. If you wanted to make this curve more circular, then place each house close to its vanishing point so its sides taper quickly. Let's look at the side and the front of a box whose lid is initially closed and then opens progressively. So when it is closed, the lid uses the same vanishing point as the box. When the lid is partly opened, it converges toward a vanishing point down here, which is vertically below the box vanishing point. When the lid is perpendicular to the ground, it has a rectangular shape, so it has no vanishing point. And when it leans backwards, it converges toward a vanishing point that's above the vanishing point for the box. And in all cases, the top of the side and the front align with one another. These boxes are parallel to the ground, so whether they tilt away or toward the viewer, their vanishing point is on eye level. These tilted boxes have vanishing points above eye level, but there are two types. There's this type that doesn't turn away from the viewer, so it has true right angles. And then there's this blue box where the top is toward the viewer and the bottom is away from the viewer. So as a result, some of these angles marked in white are less than 90 degrees, and others marked in orange are more than 90 degrees. To draw this curve, establish equal units on a vertical measuring line and have squares go to each one of these vanishing points, and you get a curve like this. To draw this suspension bridge, Start with the two lines, one vertical and one going into the distance, and mark them with equal units. And then connect number 1 here to number 4, number 2 over here with number 3, and so on until you get a parabolic curve. Then get rid of these construction lines and draw vertical lines so the bridge looks stable. And you can overlay one parabolic curve over another to give a 3D appearance. And these parabolic curves can vary enormously depending on the angle of these two lines. Let's look at this road that has a near side, then an abrupt downhill, and then a very narrow far side. Since this is a straight road, the vanishing point for the near side is directly below that for the far side. And you can see here that we see very little of the intervening area, but it narrows markedly. So if we see a near side and then a very narrow far side, we know there must be an unseen downhill. Now compare that to a level road, and the main difference is in the distance here. And that's because this road is further away from us than this road, and the difference becomes less and less as we go toward the distance because they both end at the horizon. The tops of objects tell us the type of viewpoint. So this is an eye-level viewpoint looking straight ahead at these glasses, and the tops form nearly a horizontal line. In a bird's eye view looking down at the glasses, the tops go up with distance, getting closer together as they approach eye level. In the worm's eye view, the tops go down with distance and they get closer together as they approach eye level. How can we tell whether objects are on level ground or on a hill? One way is to look at their tops. So these tops on level ground get closer together as they approach eye level. These, however, go down with distance, but they don't get closer together because these telephone poles are on a hill. And also we see less and less of their bottoms. We know these people are on a hill because if we look at their tops, they go up with distance, but they don't get closer together. So these people must be on a hill. In this picture, we're on a hill looking at a river which is on level ground. So when you divide it up into segments, all the segments go to a vanishing point on eye level. Here, the road is curving up. So if we take each segment, we would find that the vanishing points lie on a vertical line. If we looked at the other side, we would find the same thing, that the vanishing points would be on a vertical line. In my next video, I'll describe drawing roofs in perspective, and please remember to subscribe.